Welcome to my talk on solid principles with Python. In this talk, I am sharing my understanding of Rob Martin's design principles, acronym as SOLID, and I am going to use Python examples for our better understanding. Apologies for absence of video due to some technical reasons. I am sure it will not have any impact in our understanding. Let's start with what is SOLID and where this acronym has come from. The principle of solid coding is an acronym which is based on the paper Design Principles and Design Patterns written by Robert C. Martin. It stands for 5 different conventions of coding. We will cover these in more details shortly. The most important thing to note about the solid design principles is that they are meant to be used holistically, which means if you follow these principles, you can improve the reliability of your code by working on its structure over the time, and these principles also helps in maintaining the logical consistency of your code. Now, there are many other design principles as well, but what makes SOLID stand out is nowadays a lot of emphasis is given in using object-oriented programming when it comes to designing large-scale applications. It helps in modularizing and compartmentalizing our requirements into different classes. There are other ways of implementing object-oriented and still you will be able to achieve a very good code base. SOLID is something which you can use as a principles and also as a framework where you can implement these design rules in your object-oriented coding, and you will always get a consistent style in your coding. It also helps in making your code more readable because it's more of international standard, and most of the developers are committed to these kinds of standards. So it helps other person whoever is going to maintain your code in longer run. So it is more for the people who are going to maintain your code than yourself. Of course, if you're going to write the complete large application by yourself end to end, it will help you in remembering, testing it, remembering what a certain part of your code do if you adhere to certain style guidelines. Now let's start with our first principle. But before we jump right into the principles and how they can be used in Python, I want to share the base code snippet that we are going to improve using these 5 principles. I have borrowed this code snippet from an article written by Derek. The article was also on solid principle, and it also helps in understanding solid principles in Pythonic way, and also because his example exactly what I had in mind for this talk. So instead of using a different code snippet for each principle, we are going to work with a single code base and make it or improve it as we cover each principle. So this is the code we are going to start with. We have a class of FTP clients which have 2 ways to connect to FTP servers. One is secure, one is standard standard way, and we are going to have 2 functions, upload and download. Based on whether your connection is secure or normal, it is going to connect or use the respective driver. Now let's jump to our first responsibility principle, which is single responsibility principle. According to the paper by Rob Martin, we also call him Uncle Bob, this particular principle states that a class should have only one primary responsibility and should not take any other responsibility. This helps when we want to make sure that a class should have only one reason to change. This way we also accomplish the Python Zen that there should be one and preferably only one obvious way to do things. If we adhere our code base to this principle, it basically helps in gathering together the things that changes for same reason and separate those things that changes for different reasons. So if you think about this, you will realize that this is just another way to define cohesion and coupling. We want to increase the cohesion between things that changes for same reason, and we want to decrease the coupling between those things that changes for different reasons. In general, this principle comes very handy for large applications. Having separate function performing individual responsibilities helps in code reusability and easier test coverage. Now, the main takeaway here is having a separation of concern allows for modifying part of your code without breaking the entire program. So, there is always one question that you should ask yourself whenever you're changing anything. If I change one thing, how many other things will it impact? As a rule of thumb, our goal is to limit the impact of change, and hence we are going to change our code structure. So this was our original code. One class is doing everything. Examining our original code, we can see the class does not have single responsibility because it has to manage connection details for an FTP and SFTP server. Furthermore, the methods don't even have a single responsibility because both have to choose which protocol they will be using. This can be fixed by splitting the FTP clients. This can be fixed by splitting the FTP client class into two classes, each with one of the responsibility. This helps in making sure that we are adhere to Zen's. The code is sparse and it is not dense. It is simple, not complex. It is flat and not nested. Now that we have made sure that our classes have single responsibility and cannot impact each other, let's jump to our next principle, which is open and close. What it says is that our software entities like classes, function, modules, anything should be extendable, but they should not be changed. And we are trying to link it with the Python Zen, which is simple is better than complex and complex is better than complicated. Since the definition of change and extension is so similar, it is easy to get overwhelmed by the open-close principle. I have found the most intuitive way to decide if I am making a change or extension is to think about function signatures. A change is anything that forces calling code to be updated. This can be changing the function name, swapping the order of parameters, or adding the non-default parameters. An extension, on the other hand, allows for new functionality without having to change the calling code. This could be renaming a parameter, adding a new parameter with default value, or adding arg or quark parameters. Any code that calls the function would still work as originally written. The same rule applies to classes as well. Now, let's take an example of adding support for bulk operation. Our first reaction is probably to add an upload bulk and download functions to FTP client class. But it has some problems. In this case, if In this case, the return of the response or the return statement that is getting executed, especially in case of download bulk, is returning a list of files instead of a single file. So it is different from the standard download function. So let's see how we can improve on that. So instead of adding a function here, let's do another thing. In this case, it's better to extend the class with functions than extend through inheritance, because the bulk FTP client child class would have to change the function signature for download, reflecting its return a list of bytes rather than just bytes. So if we added there in the previous actual standard, I'm babbling. Yeah, so if we add that function into the parent class, it violates the open close principle, because two different downloads are returning different kinds of things. We don't want to do that. So it's better to have a different child class which will have the original functions along with the additional functions for the bulk upload and download. Now let's move on to the next principle, which is about substitution principle. Now the standard definition of it is, if S is a subtype of T, then object of type T may be replaced with object of type S. A plain English way of saying this is, any child class can replace its parent class without breaking functionality. You may have noticed all of the FTP client classes so far have same signature function. Same function signatures. That was done purposefully so that they would follow the substitutability principle. Let's take an example. Let's say that we have another FTP class which is for secure connection. If we want to have this class in place, we want to make sure that it can replace FTP client object. Let's see, let's look into this example further. So a specialized case for FTP file transfer is supporting a secure connection. Now there are a couple of choices to do that. One is to add upload secure and download secure functions, or add secure flag through quarks in our upload download section. Or the one that we have done is extend the FTP client and create a new child class which is FTPS client. It makes sure that when you are connecting using the FTP driver, you are using username and password. Now this is exactly the kind of edge case inheritance is meant for, and it follows this principle, and it makes for effective polymorphism. You will note that now FTP client object can be replaced by FTPS client. That means these are interchangeable, which brings us to our next principle, which is about interface segregation. Let's see about that. Interface segregation principle. What it says that a client should not depend on methods it does not use, which means your code should be readable and it should not have redundant part which the actual class or the parent is never going to use. To me, this particular principle was confusing because it talks about interface and we don't have interface in Python. Then I looked more into related examples of interface segregation, and I realized that this particular principle, interface segregation principle, is about making reasonable choices for how other developers will interface with your code. That's right, it's more related to the I in API and CLI than it is the interface keyword. It is also where the readability counts Zen of Python is driving force. A good interface will follow the semantics of the abstraction and match the terminology, making the code more readable. Let's look at how we can add another class called S3 client, because it will have same upload and download semantics as FTP client. This is our code so far, and we want to add another client, another class, S3 client. We want to keep S3 client signature for upload and download consistent, but it would be nonsense, or it doesn't make any sense for new S3 client to inherit from FTP client, because S3 client is not the special case of FTP. Let's just say what FTP and S3 do have in common is that they are file transfer protocols, and these protocols often share a similar interface as seen in this example. So, instead of inheriting from FTP client, what we can do is, it would be better to tie these classes together with an abstract base class. We create a file transfer client which become our interface, and all of our existing clients now inherit from that rather than inheriting from the FTP client class. This forces a common interface and allows us to move bulk operations into their own interface, since not every file transfer protocol will support them. So, what does this afford us though? Well, we were even able to get bulk file transfer client as a part of mixing, so we don't have to worry about whether we are inheriting something which we shouldn't, and that makes sure that no class have methods that it doesn't use. So instead of having one large class of FTP download, we have multiple small classes which are inheriting the methods based on their requirements. Now let's look into our next principle, which is really helpful when we are making sure that the inheritance is working as it should. So this is dependency inversion principle. This is what ties it all together. Everything we have done with other solid principles was to get to a place where we are no longer dependent on a detail, the underlying file transfer protocol, or anything that is being used to move files around. We can now write code around our business rules without tying them to a specific implementation. What dependency inversion principle says is, it says the same thing. High-level modules should not depend on low-level modules. They should depend on the abstraction, and abstraction should not depend on the detail, which particularly means that now that we have abstract classes in place, like these ones, they should not use any kind of low level class which is actually using them or implementing them. Or let's say that you have SFTP client, so instead of inheriting from FTP client, they should inherit from file transfer client, that it is doing as it should. So abstraction should not depend on details, where on the other hand it should be other way round. So you have to mention explicitly what things you are going to inherit from which abstract classes. So you are being explicit, and there is nothing which is implied or which is just assumed. It helps us in making sure that our code is doing exactly what it is supposed to do and don't have any access to the things it is not supposed to do. In terms of security, it also enforces a very big thumb rule of security, which is less is always more. So what we can do with this particular principle, let's see how this particular principle work in our example. As we have our different classes for each type of file transfer and none of them depend upon each other, what we can do is we can have different types of objects of each type of file transfer client, and because they have same kind of signature, we can just use them as their object directly into the function call, and we can trigger the upload and download functions without worrying about whether we are calling the correct function of the object or there is any naming convention change, or there is any kind of there is some kind of thing that one object supports while other don't. Of course, we have to look into our code when we are whichever is going to support bulk upload and bulk download. We have to make sure that respective abstract base class is inherited in the child class if we want to make the upload bulk and download bulk option. But having a hierarchy like this helps us in making sure that our code is extendable and the abstraction is properly implemented. This, of course, was a curated example. Not every problem will fit this exact breakdown, but I've tried to include enough reasoning behind my decisions that you can choose the most solid and Pythonic implementation in future. I hope my examples and this particular talk helps you in understanding why and how you can use solid principles, and in your day-to-day life you can start, maybe you are already doing it, because these are very fundamental principles that any intermediate level developer start using in its day-to-day coding to improve its code efficiency and consistency. So I hope this talk was a helpful to you, and make sure that you write clean code, because it's always helpful to support the person who's going to maintain your code in future. So writing a clean code is something for other people. In fact, the book Clean Code in Python has also given an explanation on this solid principles. If you get chance, please have a look into it. It's a very good book. I've read it and it helps me in clarifying, or it has helped me in improving my coding habits a lot. I hope everybody is staying safe. Thank you so much for this attending this talk. Thank you. Have a good day.